Welcome to AMAC KSSM channel. This is KSSM at Max Form 5 exercise discussion. I'm Madam Wong here. Formative exercise 8.2. Number 1. The diagram on the right shows a displacement function s equals to ft, a velocity function v equals to gt, and an acceleration function a equals to ht for a particle which moves along a straight line and passes through a fixed point O for t from 0 to 4. Based on the graph, determine a, the initial velocity of the particle. So initial velocity, so means that we want the velocity when t equals to 0. So velocity graph when t equals to 0 is on -2. Therefore, the initial velocity is -2 meter per second. B. The time in seconds when the particle passes through the fixed point O. So, the particle passes the fixed point O when s equals to 0. Therefore, look for the s function equals to 0. It happened when t equals to 3. Therefore, the time is t equals to 3 seconds. C. The minimum displacement of the particle. So minimum displacement, just look for displacement graph, and this is our minimum point. So the minimum displacement is -4 meter, which is 4 meter to the left of the fixed point O. Then D, the total distance traveled in meter by the particle in the given time period. So when we need to refer the total distance, we refer to the S graph, where the displacement, first part, alright, we are from -3 to -4. So it's actually traveled 1 meter toward left. And the second part is from -4 going toward 5 meter, which is 4 meter on the left and going toward 5 meter on the right of the fixed point O. Therefore, we use 1 plus the 5 minus -4. So it traveled 9 meter plus 1 meter here. So the total distance is 10 meter. E, the range of time in seconds when the particle moves to the right. So when the particle moves to the right, v greater than 0. So v greater than 0 refer to the graph v. When it's greater than 0, we want only the positive part, which is from 1 to 4. So when t greater than 1, this is only a linear graph, therefore we can just write t greater than 1. Alright. Question number 2. The diagram on the right shows a displacement time graph of a particle moving along a straight line for t seconds. The equation of the curve PQ is s equals to ht squared plus k, where h and k are constants. The points P, Q, R, and S are 0, 1, 2, 3, 4, 3, and 6, 0 as respectively. Find A, the value of H and K. So we see H and K in the function of displacement. So we have 2 points for the displacement. When t equals to 0, our displacement equals to 1. Therefore, t equals to 0, we have 0 plus k equals to 1. Therefore, we know k equals to 1. And the second information, we have 2, 3. So on 2, 3, 3 equals to h times 2 square plus 1. So 1 move here, we get 2 equals to 4h. So 1h equals to 1 over 2. B, the instantaneous velocity in meter per second when the particle, of the particle when t equals to 1. So we're looking for the instantaneous velocity. So form up our displacement function with the h and t that we get earlier. There we get s equals to 1 over 2 t squared plus 1. So the v equals to ds dt. Therefore, after we differentiate this, we get v equals to t. Oops. I don't think we need this. Anyway, so when t equals to 1, alright, when t equals to 1, the velocity is, when t equals to 1, the velocity will be the gradient of the displacement graph. So we can sub t equals to 1 into the velocity function. So v equals to t. When t equals to 1, v is equals to 1 meter per second. And then number 2, when t equals to 3, t equals to 3 here, the displacement, okay, is basically horizontal, right? It falls on the horizontal line. Therefore, the rate of change of displacement is basically 0. Therefore, we know when t equals to 3, v equals to 0 is stopped at the instant when t equals to 3. In fact, we can look from the graph, right? The particle remains in the 3 meter from the second seconds up to the 4th seconds. So all this while, he is not moving. He is remaining the displacement there at the 3 meter away of the fixed point O. Okay. Then number 3, when t equals to 5. So when t equals to 5, the displacement shows here. Then what about our velocity? Again, velocity is the rate of change of displacement, which is the gradient of the straight line. So look from the gradient of the straight line, we get v equals to negative 1.5 meter per second. Number 3, a particle moves along a straight line so that its displacement s meter from a fixed point O and at t seconds is given by s equals to t cubed minus 5t squared minus 8t plus 12, where t greater than or equals to 0. A. Express the velocity function v and acceleration function a of the particle in terms of t. So we are given the displacement function. We need to find the velocity function. Therefore, we do ds dt. So v equals to 3t squared minus 10t minus 8. We differentiate from here. Then again, when we need to get the acceleration function, we know a equals to dv dt. Again, we do differentiation. So we get a equals to 6t minus 10. B. Determine the instantaneous velocity in meter per second and the instantaneous acceleration of the particle when t equals to 3. So, when t equals to 3, v equals to 3 square minus 10 times of t, which is 3, minus 8. So after the calculation, we get v equals to negative 11. Again, when t equals to 3, we need to find the acceleration. So sub the t equals to 3 into the acceleration function. There we get 6 times 3 minus 10. And we get 8 meter per second squared. C. Find the value of t in seconds when the particle is instantaneously at rest. So when the particle is instantaneously at rest, it means v equals to 0. The velocity equals to 0. It is not moving. Okay, so v equals to 0, which is 3t squared minus 10t minus 8 equals to 0. By factorization, we get 3t plus 2 times t minus 4 equals to 0. 3t plus 2 equals to 0 will get us t equals to negative 2 over 3. And that's the solution that we don't want. So we only focus on the positive value of t. From the t minus 4 equals to 0, we get t equals to 4 seconds. D. Find the value of t in seconds when the particle is at O. So when the particle is at point O, there we know the displacement is actually 0. So s equals to 0, we get t cubed minus 5t squared minus 8t plus 12 equals to 0. We haven't learned how to solve the cubic equation. Then we use calculator. we get all the roots, t equals to -2, t equals to 1, and t equals to 6. So from the roots, we write back t minus 6 times t minus 1, and t plus 2 will be equals to 0. So we know t will be equals to 1 and t will be equals to 6. The particle will back to point O. E. Find the total distance traveled by the particle in the first 6 seconds. So since this is a cubic graph, I use the GeoGebra to sketch the graph. Alright, for the instant from 0 to 6, when the t equals to 0 to 6. Alright, so when t equals to 0, I find my displacement is 12. Alright, and the minimum displacement is -36. It happens on t equals to 4. Therefore, this part, the particle actually traveled 12 minus -36 meter. And then from the 4th second back to 6 seconds, it traveled from -36 meter away back to 0. So it's actually traveled 36. So the first part, we know 12 minus -36, which is 48 meter, plus another 36 meter away again. There we get total 84 meter. Thank you.